Thank you. All right, guys, what we're starting today is Chapter 7. So we're starting Chapter 7 today. And Chapter 7 is mainly going to be covering quadrilaterals and other polygons. Quadrilaterals and some other types of polygons, a lot of four-sided polygons. We'll be looking into specifics. And finally getting to the really an understanding of why we can't call any four-sided polygon a rectangle or a square, because they actually have some other names and other characteristics. But the first thing we're looking at is the sum of the angle measures of a polygon, some of the interior angles inside the figure. And we can start off with a triangle, because we do know the sum of the interior angles of a triangle, which is 180 degrees. If we add all three angles together, we get 180. How about a rectangle or a square? It would be now, if we look at, let's see here, well, shapes, there we go, 5. Well, that's 3 still, 5. There we go. Does anybody know what the sum of the interior angles of a 5-sided figure would be? It would not be 720. It is 540. And they actually have a specific way that they work. Because if we look at these first two, how many sides does a triangle have? 3. And its sum is? A square has 4 sides and is? And it works out that if we take the number of sides minus 2 and multiply it by 180, we actually get the sum of the interior angles of any polygon, which is actually, I think, the first part of your note sheet, is this here. The sum of the measure of the interior angles of a convex polygon is given to us by the equation n minus 2 times 180, where n is the number of sides. And this works for any figure. Now, well, if we look at this first one here, the sum of the measures of the interior angles of this convex polygon. Well, how many sides do we have? 2, 3, 4, 5, 6, 7, 8. So to find the sum, we use the formula n minus 2 times 180. Well, n is 8. Now at this point here, we could type this into the calculator and it would tell us the answer. Because we can grab the calculator, say 8 minus 2 times 180, hit enter and get 1080. We could say 8 minus 2 is 6, times 180 is still 1080, 1080 degrees. So the sum of the interior angles of this octagon is 1080. Questions on this so far? The coin shown here is an 11 gon. Find the sum of the interior angles. Well, what would we do? N minus 2 times, so n in this case is, so 11 minus 2 is 9, and we do 9 times 180. Carry the 7. So it should be 1620, or we can just grab a calculator and say 11 minus 2 times 180. is 1620. That's it. Questions on this here? Do we need to see another example with one of these here? I mean, for this here, it's not too bad because we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we would do 10 minus 2 times 180. Again, we can type it in the calculator. Well, 10 minus 2 times 180 is 1440. So the sum of the interior angles for this here is 1,440. Questions on any of this here? Are you good with this here so far? So now we're going to work the other way around. So for this one here, they tell us the sum of the measures of the interior angles of a convex polygon is classified by the number of sides. So we do have a formula to find the sum of the interior angles, yes? It is n minus 2 times 180. And we're saying that this here equals what? 900. Yes. Because we need to get in by itself first. So the easiest thing to do first is divide both sides by 180. Which will tell us that n minus 2 is equal to, well, we can grab a calculator and say 900 divided by 180 is 5. So the first thing we'll do is divide by 180. What do we need to do next? By? N minus 2 equals 5. What do we need to do? Yes, answer 7. As we would. Add 2, telling us n is 7. We divide by 180 and then add 2. Questions on this here? No. Let's look at another example. They tell us that the sum of the interior angles of this convex polygon is 1,800. So to solve it, we'll use the formula. N minus 2 times 180 is equal to 1,800 or 1,800. What do we? Yeah. Possibly. The first thing we would need to do is divide by 180. So we need to see what 1,800 divided by 180 is. It is 10 on calculator. Oh. 100 divided by 180 is indeed 10. So the number of sides is 12, or a dodecagon. Questions on this here? Any questions on this here? Questions on anything we've done so far? Do we need to see another example of finding the number of sides? Let's see. So, first thing we would do is divide by 180. So 1620 divided by 180. 20 divided by 180 is 9. Add 2, so n is 11. So one of the things, especially with this here, is to remember to add the 2, because there's a good chance at least one or two of you will give the answer before adding 2. So make sure to go all the way and finish the problem. And or you could say it's 11 gone, so we can call it 11 gone, or it's also an undecagon. We feel comfortable with these here. All right. We're going to be solving some of these here. So we want to find the value of x. What do we know about the sum of the interior angles of a four-sided figure? It's 360. Right, because x plus 108 plus 121 plus 59 is 360. Yeah, so we can add these three together because they are like terms. So 108, 121, and 59. 8 plus 29 plus 51, I believe. 59. Okay. So at least I got the 108, right? Plus 121 plus 59. End up getting the same thing. 288. That's convenient. And lastly, we need 2. Subtract 288 from both sides. It is 5, 10, 2. Exactly. So the correct answer is 72. And if you're doing the homework, especially on these here, and the answer doesn't feel like it's the right answer, you can always plug it back in and do 72 plus 108 plus 121 plus 59 and see, do we get back to 360? If we do, then it is the right answer. If we don't, then something went wrong. Any questions on this here? Are we ready for the next one? So the sum of the interior angles of this figure here is 360, yes? No, because 360 is for what? Squares, rectangles, four-sided figures. How many sides does this have? 6. Interestingly enough, this number of sides will be the same as the number of angles. Because there are 6 angles in the figure, it has 6 sides. So especially on the homework, sometimes it's easier to count the angles than the sides. So there are 6 sides. So we can do 6 minus 2 times 180 to figure out what the actual sum of the interior angles is. Now we could do 6 minus 2, which is 4, and do 4 times 180. Or we can just say 6 minus 2 times 180 in the calculator and see that it is 720. So the sum of the interior angles for this figure is 720 degrees. And if we're working this out here mathematically, we would say that we are adding all these angles together, and if we do, we should get 720. Now we can put all those other angles in the calculator, our like terms. 118 plus 111 plus 124 plus 115 plus 145. which is 613. Well, last but not least, we would subtract 613 from both sides, telling x, this x is 107. 7 and 3 is 10, 20, 1. Questions on this here? Any questions on anything we've done so far? You kind of like this so far? Yeah. Let's throw in a whole bunch of letters. Now, the figure isn't necessarily given to us in this figure, but I went on and added one for you. Especially on the ACT, when y'all take that, if they do describe something. So here, the measure of the interior angles of a quadrilateral. Well, we know a quadrilateral has what? 4 sides. I would start off by drawing a 4-sided figure. Give us a picture. I have one here already for us. So the interior angles of a 4-sided figure are x, 3x, 5x, and find the measure of all the interior angles. Well, what do we know these 4 angles add up to be? So we can say x plus 3x plus 5x plus 7x is 360. Sum of the interior angles of a 4-sided figure is 360. Now we can add all these together. Well, 3x and 7x, 3 and 7 is 10, plus 5 is, plus 1 is. Yes. Is 22.5. So we need to find all the angles, yes? I found one of them. Because one of them is just x. So one of the angles is 22.5. We also have 3x. So we're going to do 3 times 22.5. So 67.5 is the next angle. We also have to multiply it by 5. 5, carry the 2. So that's 122.5. 112.5. Goes one off. 12.5. And the last one we have to multiply it by is 157.5. That's it. Once we draw it out and see what it's saying, it's not that bad. Any questions on this so far? We ready for the next part? Now, an equilateral polygon is a polygon that has all congruent sides. An equiangular polygon is a polygon that has all congruent angles, and we've covered both of those. Now, if a polygon is equiangular and equilateral, we call it regular. A regular polygon has all congruent angles and all congruent sides. That's what it means to be regular. So, is the home plate for a baseball field a regular polygon? No. Because, so all sides could be equal, but what are all the angles? Because A, B, and D are all what? 90, 90, and 90. So are all the angles congruent? No. But we do know that it is 5 sides. So we can say 5 minus 2 times 180, which is 3 times 180, which is 540 degrees. But what do we do know about E and C? They are the same, yes? X plus X is 2X. 90 plus 90 is 180, plus 90 is 180. So the measure of angles C and E are and we know they're the same because they tell us they are. The little red circles or arcs tell us those two angles are congruent. Questions on this here? Questions on any of this so far? All right. I'm going to skip that one and go to the next part. The exterior angles of a polygon is the last thing we're going to talk about. Because that one there, no, it's not regular. And we just find the rest by saying they're all the same. All congruent sides. Now, if we take a shape and all we do is decrease the sides proportionally, will the angles change? Because if I just make it bigger or smaller, the angles are going to stay the same. Yes? So for here, or if we just mainly, they say cut out the angles and put them together, we get a circle. All right? The sum of the measures of the exterior angles of a convex polygon, one angle at each vertex, is what? Okay? What is the sum of the exterior angles of a dodecagon? Both sides. So the sum of the exterior angles is? Sum of the exterior angles is? How about a hexagon? How about a nonagon? Chiligon? Chiliagon? I think it's 100. But does it matter?
So anytime it's talking about exterior,
The sum of the exterior angles, yep, is 360. I believe it's 100. And the only thing we do have to classify is that there's only one angle, exterior angle at each vertex. So we're only talking about one of these here. But we do know for this one here, these angles add up to be 360. So yep. So the sum of the exterior angles of any polygon is 360. And there will probably be, it happens every year, both this class and the ones in Miss Kendall, there's going to be at least one person who gets those wrong on the test. I don't know what it is, but it just happens every year. The sum of the exterior angles of any polygon is always 360. So here, we can add like terms together. 2x plus x is 3x plus 89 plus 67, like terms. Carry the 1 is 156 is 360. Exactly. Get x by itself, so we would. Yep. Which is 204, and we could do that in a calculator. 360 minus 156, and then we would almost, yes, divide by 3, 6, 8. And since it only asks to find the value of x, we don't have to plug it back in. Questions on this here? Do we feel good with these here? Do we need to see another example of one of these? We're good with this? Yep. This here is no different. It's just telling us how many sides it has. Because the number of sides is the same as the number of exterior angles. So this here would have, hexagon is 6 angle.
Just add all those up, divide it by 360.
Well, so 360, and we subtract 34, 49, 58, 67, and
Wait, so that's a 7-sided triangle.
heptagon. Heptagon. Yep. Because if we wanted to do this in the calculator, we could do it that way. 360 minus 34 minus 49 minus 58 minus 67 minus. So the missing angle is. Are we good? Making sure we're not going too fast through this. Yep. Sum of exterior angles. 6. Okay. Find the measure of each interior angle of a regular polygon. So all the angles of a regular polygon are the exact same, yes? So if we wanted to find one angle of a regular polygon, n minus 2 times 180 gives us the sum of all the angles, yes? And if they're all the same, we can divide it by number of sides. So if I want to find one angle in a regular polygon, we can use the n minus 2 times 180 and then divide it by the number of sides. So here, a dodecagon, dodeca is, so we're going to say 12 minus 2 times 180 divided by 12. Yeah, you can put it in the calculator as is, because that would be 10 times 180 over 12. Which is 1,800 divided by 12, and I don't think that's 150. Find the measure of the exterior angles. What do you think we're going to do? Yes. So for the exterior angles, the formula is 360 divided by n. And for us here, that'd be 360 divided by 12, which indeed is. What do you know about the interior and exterior angles for this here? What do we have 150 and 30. What do they make? Which is a straight line. Look at all this exterior angles here. They make a straight line with a shape, yes? So the exterior and interior angles will add up to be 180 every single time. Questions on this here? And as we increase the number of sides, the interior angle is actually going to get bigger. The exterior angle is going to get smaller. Dodecahedron. So each face is a pentagon. Yes. Pentagon. So each side, well, each one has 5 sides. So we could say 5 minus 2 times 180 divided by 5. Well, 5 minus 2 is 3. 3 times 180 is 540. And 540 divided by 5 is, oh wait, I know I'm going pretty fast for this, but we feel comfortable with these here? Yes, not losing any. So, the formula. So, find the measure of each interior angle. So we know that they're all the same because it's regular. So we can use n minus 2 times 180 divided by n. So we're really just finding the sum of it and dividing it by the number of sides. Since it's a pentagon, it has 5 sides. Three times 180, which is 540, which is, well, wait, does anybody have a guess at what the exterior angle is going to be? 108 minus 180 is 72. Or we can do 360 divided by 5, which is also going to be 72. Questions on any of this here? The homework sheet is not attached, but I do have it. A lot of formulas, not too much there. You're welcome. Yes, which one?